Okay, good. We're recording now. I think, are we? I hope so. Yep. Uh, are we recording? I don't see the little.
I can see the
I
little
can see
flash.
it.
Oh, okay, good. Right. So all these pearls of wisdom that are now lost, I just dropped them into the ether, and the only witnesses are you here, and it's an ephemeral moment that we've shared together, and I feel all tingly. John von Neumann's idea was that the computer's code and the data should be stored in the same way. And that was a revolutionary idea, because if you look at this photograph, the program is actually stored in the wires. So the code is what hole is connected to what other hole. Whereas the data was stored in some electronic means, the procedures that the computer was to follow to implement the program was defined by the paths made by all the wires. So these women are actually coding right now.
Would they just run around the board?
Go ahead.
Like changing wires? Would they just run around the board?
The wires, it was like a giant, enormous, very complicated switchboard. And depending upon what hole was connected to what hole would influence what the program did. I mean, not the program, it would define what the computer did. Okay.
So would they have to know? Would they have to know all the combinations? Like, would different combinations of connections mean like a different function?
Yes, absolutely. A program, well, a computer could do one program at a time, and the programs might last hours. The programs might last days. So it would be planned in excruciating detail. So every single wire would have been researched and planned and then implemented, as you see here. So the von Neumann idea eliminated all of this, and your phone, for example, or your laptop is reading data from the same memory as it's reading instructions. Okay. All right, well, that was a fun digression into history. Hey, but while I'm on the subject of women, the early field, you've probably heard that the very first programmer was Lady Ada Lovelace, who was let's see, I always thought it was a niece of Lord Byron, but I think I read recently that there was a different relationship to Lord Byron, the poet. She's credited as being the very first programmer. If you have ever heard of punched cards in the early days of computing, we'll go back a couple of hundred years, and there was a loom for weaving that could be programmed by punch cards. And she developed the algorithms to weave certain patterns, but not just that. That's the fun fact. But the truth is, it goes way, way, way beyond that. She was a mathematician, a logician, and truly the first programmer. She worked. Hey, I meant no, I didn't mention. But she was worked with Charles Babbage on the first differential engine. Amazing. And then the role of women throughout computing has been fundamental and foundational. Now, for some reason, the role of women has diminished in recent times. And I personally think that humanity has suffered because of it. We need to succeed as a species. We need the creative output of all of our people. not just some. So it's a, if you're, we have a number of women in the classroom. I would encourage you to pursue computer science. We need you. The world needs you. Okay. All right. Any questions about what I've talked about? Okie dokie. So let's go back to that bit of an agenda. Not a very, very complex agenda, but it's the agenda we have. Okay, so we're done with review on Tuesday. I was just informed that my internet connection is unstable, which is interesting because I'm hardwired. Okay. All right. So tell you what, there's a couple of things I want to show you in online. And so let's go here. And you're still seeing there you go. This is the YouTube playlist so far for our class. I believe that I've sent you a correct link to this playlist via email. And here you'll see something for the future, Project 2, the DICE histogram. The reason why there's a video for it is it's sort of a program that runs over time in motion, so I wanted you to see what it would do. But you also see there are 2 video recordings for the first lecture. So if you're in this class, you're in section 1. If you just can't get enough of me, you can also watch section 2. Okay? All right, so let's shift over to Replit. Can everybody join me in Replit, please? Okay, so I'm hoping that you already created a REPL, which you can use for all of your in-class exercises. So just one will do. You don't have to start new ones each class. I do encourage you for your projects to create 1 per project. Okay, so I'm double clicking and it's starting up the REPL. You'll notice that it does have a file, in this case main.py, comes by default. And we can eliminate these lines, which were left over from last time. And what we saw on Tuesday is we could use Python as kind of an interactive calculator. But I think you would agree that if this is all we could do, type into an interactive calculator, then we couldn't code, Minecraft, right? When you go to a website, you don't have to enter the code yourself before you can run something on the website. So certainly there's a way of storing programs and running them over and over again. So that's what we would use a .py. Notice that the file name ends in .py. That suggests that it's a Python file. Okay, so tell you what, we learned how to input a string in the last class. What I want to do is count the letters in my last name, or you will count the letters in your last name. Actually, there's no strict requirement that you enter a last name, I suppose. So count the letters in a word. Okay, so how about word is going to be the name of the variable. And what do we use to input something from the keyboard? Remember, it's your guys' responsibility to be interactive with me, otherwise I'll stick beans up my nose till I turn blue.
What?
Input, yes. All I heard was put. So but I'm sure you said input. Okay. So input. Now you can use input by itself, just like this, or you could also give a prompt, like enter a word. Now you'll notice I put, I put a space at the end. That's only, that's because I'm kind of fastidious about what my programs look like. So let's go ahead and run this. To run this, let's click over to the shell. Okay, see that tab, shell? As opposed to the console. The console is great for running things interactively, but now I'd like to use programs, so the shell is better for that. Okay, now we have a file called main.py. So if you say Python, now let me just quick check the verb. Yeah, okay, so just Python and main.py, and that will run the program. And now you can see why I added a space at the end, because I like having the space after the prompt. And I'll type something in. I hit the enter key or the return key, depending upon which tribe you belong to. And the program exits, and we're back to the prompt. Okay, so let's go ahead and print out that word. Now we didn't look at print before, so let's take a look at that. We can print
I have a
the
quick
word.
question.
Please go ahead.
So in your shell, when you enter down, you get that blue in class with the $sign.
Mm-hmm. Okay, make sure that you're in the shell tab as opposed to the console tab. And what you see here is likely to be different than mine. The way that you read this is we're running on a Linux machine. That's not Windows and it's not the Mac. We're running on a third type of computer. And the program we're using is called a shell. It's just the interactive command line prompt rather than what you're accustomed to, which is the mouse and Windows, and moving icons around. So this is the another way. It's actually very, very productive way to use your computer via the keyboard. And what you're seeing here, this one says swiggle or tilde / in class. Now, the word in class comes because if you look at the top of my screen here, I named my REPL in class. So if you named your REPL something else, you will have something else here.
Yeah, mine just the blue stuff like disappeared completely and it was just giving me arrows. So I just exited out and reopened it and now it's working.
Okay.
I don't know what happened.
Well, when you type something and hit return, that the shell, that's the program we're typing into right now, doesn't think is complete. It'll do what you said. So if you ever find yourself in a weird state in the shell, if you hold down the control key and the letter C at the same time, you see how it's sort of getting me out of whatever it is I was doing? I'll give you another example. I'm going to run this program again. And now I'm actually running my Python program, but I say, oh gosh, I can't deal with this. Control C, and notice that broke me out of the Python program. So Control C is your friend. Okay. Now, we have some new code here. Oh, I'm sorry, I should have followed up with you, Victoria. Did that answer your question?
Yes, thank you.
Good, good. All right. Okay, so I'm going to run the program again. Now, when you're in the shell, computer people historically are very, very protective of their fingertips and their fingers and their joints. And, you know, why type something when there's a shorthand way of getting the same thing done? So what I'm about to do is touch the up arrow on your keyboard. And that fills in the entire line of whatever I just did. So if you want to do it again, that's an easy way to do it. Okay, so enter a word. So line 1 was the input that prompted us with enter a word. The input, the purpose of input is to collect something from the keyboard from you. And it stops when, in this case, when you hit the enter key. And whatever you typed is accumulated in a variable that's on the left-hand side of the equal sign. Now that's a variable, it's a cup. It's a cup labeled with the name word, means I can reach into that and see what's in it. In this case, I'm going to print it. So print the word. All right.
Would you have to use input if you were just putting like a number in there?
Yes, it's the same command. However, it's really important to understand, and we'll see that in today's class, that input returns a string. So if I'm going to run the program again, I'm using the up arrow once. If I enter 3, the 3 is a string, it's not a number. So for instance, if I were to expect to print out 3 minus 1 or 2, this will be an error. What I have here will be an error. Enter a word, 3. Now I think it's going to print 2. Actually, I know it won't. Okay. So the error is trying to do math with a string. So if my intent was to, instead of a word, to enter a number, let's modify our program. Now there's no reason other than appearances that I changed the variable name. I could have left it as word, but then it wouldn't have just looked right. So in order to make the string returned by input into an integer, I need to do this conversion. So you look at inside the parentheses, int parentheses, it does the input and it returns a string. Then int gets that string and converts it to a number. So I can run this now. And I entered 4 and it printed the number minus 1, so 3. Okay. But I would like to remove what I just added. Let's see, does this support undo? Oh, look at that, that's wonderful. So Command Z on a Mac will undo, or Control Z on Windows, I would imagine, would also be an undo. There. Do I have any questions? So it's going to come up sooner or later, but let me ask you a question. Um, what color is George Washington's white horse?
White.
Yeah, that's right, white. Yeah, you might say, what kind of stupid question is that? Well, actually, sometimes researchers in teaching say that you should expose something about yourself. You establish this bond between you and your students. So when I was very little, my father would ask me questions like that one, what color is George Washington's white horse? Another one was, who's buried in Grant's tomb? And the reason why I bring it up is very often when I ask you folks a question, you'll find that I've embedded the answer in the question. Now, I've already done it. You may not have noticed. I said, what would you use to input something from the keyboard? The answer, of course, is input. Okay. Okay. That was just an aside. It's going to come up sooner or later. I wanted to hang a lantern on it. Okay, so in the print statement, we can print more than one thing at a time. So how about the word you entered is, and then a comma. Now the space after the comma is not strictly required, but it looks good. And I'll run the program again. Okay, I'll run the program again. Python main.py. Enter a word. The word you entered is happy. Yep, this is what I entered. Does anybody notice an inconsistency between the first line and the second line? It's very small, but I'm wondering if you see it. Remember, I was talking about how I'm fastidious about what my programs look like.
In order to get the space after the colon in the first line, you had to put in a space. In the second line, you didn't.
Perfect. That is perfect, perfect answer. Right. So here I needed to add the space, but in the print, wherever you have a comma to go to another thing to print, you're going to get a space. Okay. All right. Now, how about I'd like to print out the number of letters. I would like to count the number of letters in the word. There is a Python command, Python function, which is very, very, very commonly used. And that's why I'm bringing it up. So, and I can build it directly into a print statement. So it has, here it comes. You ready? L-E-N. See, I didn't say, I wonder if there's something that we could do to figure out the length of a string. Okay. That would be one of those white horse questions. And watch this. I'm going to add some more after it. So it has, okay. Let's try that now. Enter a word. Okay, Joy has 3 letters. Is everybody with me? Are you able to duplicate this on your own? Okay, is everybody good? Nobody said good. I see some thumbs up. I see some nods. Yes. Okay. All right. How about I'm going to modify this a bit. I'm going to say this is word 1, and everywhere that word is, I'll say word 1. And how about we add another word? Okay, so now we've got 2 words in there, word 1 and word 2. Darn, I had an opportunity, I missed it, I could have called it thing. All right. Follow the thought out, right? Then I would have thing 1 and thing 2. Right? Okay. Enter another word. Okay, so I'm just going to go up here and copy the whole line and paste. So you see how you can use this, just like a word processor. And I'll say the second word you entered is word 2. Now let's see, I think I can get rid of that and make more room. I made more room by clicking on the icon on the left. All right. So let's see, let's try running that. Now, I made such a small change, but this is an important lesson. I'm sure this is going to work, and it's such a small change, but please remember, you write a little, you test a little. You write a little, you test a little. You write a little, you test a little. Okay. The reason for that is, suppose you slammed like 19 Red Bulls, and you just code flows from your fingertips like food poisoning, right? And it's just go right onto the keyboard, and you've got thousands of lines of code, but you didn't test. And it turns out there's a bug. Where is it? Well, somewhere in that haystack of 1,000 lines of programming code that you wrote without testing. So the point here is that if you write a little and you test a little immediately after, and you find a problem, it's a very small space that you have to investigate to find your bug. Okay, write a little, test a little. All right, so here's a word. Hey, what happens if I put a space in here? First word, it didn't break it up into words, input. It takes the whole line. That's something new that we just learned. Okay. Let's do a quick set of practice. Suppose I wanted to join the first letter, the first word with the second word into a new variable. Do you remember how we did that? How we added one word to another, one string to another on Tuesday? By the way, I just gave you one of those white horse questions.
The underscore?
That would be used in creating the names and in naming variables. But at some point, I showed you how you could add one string to another. It takes a certain amount of creativity to ask questions where you build the answer into the question. I'm proud of that.
Can you repeat the question again?
The question is, how do you add one string to another to concatenate them?
Use a plus sign?
There's the white horse, right? I said, how do you add one word to one string to another? Joined words. Okay, let's try that. One and 2. Okay, so you notice the last thing printed is 1 followed by 2 with no spaces in between.
I don't know if it's just me, but it's kind of hard to see the bottom of your screen because of the little chat box that we have for Zoom.
Okay, all right. Yep, that happens. So thank you for pointing that out. Will this, I think Zoom is not going to help here. That doesn't help what I just did it?
It did. It helped a little. It's good.
Oh, okay, good. I know if I share my desktop rather than this window, it definitely will help. So I'll share the desktop. And good. So now you can see what's behind it and what's in front of it, and good. All right. Okay. So far, everything that we've entered, as every statement, every instruction that we've entered ran in sequence, one after the other. So first line 1 executed, then line 2, then line 3, right? And so on. So wouldn't it be great if we had a way of making choices, decisions, so that we might follow one code path versus another? Because if all we could do is execute one statement directly after another without any opportunity to veer in one direction or another, one code path or another, then our programs would all do the same thing every time. So what I'd like to do is to introduce the first more advanced statement, and it's called the if. And the if statement is actually part of a family. There's if combined with else. This is not syntax. This is just me writing. And there's also the if combined with elif, potentially combined with else. So we're going to learn all 3 of these right now. So the idea is, if some true false, here's what it kind of reads like. Again, this is not syntax. This is what it reads like. Then do this. So that's the first form of the if. And then let me put on the optional else. Else do that. I'll get to Elif in a moment. So this is how the if statement works in sort of plain language. Let me draw you a picture. And this picture is using a paradigm called a flowchart. So you're arriving at the if statement. And you want to make a decision. So that is pictured as a diamond. And this is where the sum true false is. And here comes the decision. If true, do this. Now, what about if it's false? If it's false, without an else, first I'll draw it without an else. Else, skip it. So I'll come back here. And so imagine this and this was not present would look like. So I'll go ahead and actually erase this. So if some true false is true, do this. Otherwise, if it's false, simply skip the do this portion. Okay, let's, do you have any questions at this point?
So what happens if it's not true? Like, does the program just like end into an error, or does it go into something else, or does it skip it?
Well, it depends. And hey, do you remember I told you every computer science question can be answered with it depends? I hope I told you that, but it's a true statement. Every single question in computer science could be answered with it depends. Maybe I should put that on the midterm and finals. So every question in multiple choice, one of the choices should be it depends. Okay, very little chance of that happening. Okay, so it depends. And what does it depend on? What do I have down here? So you notice that if it's true, if the decision evaluates the true, you're going to do some extra code, and then the arrow comes down, flows downward. And if it's false, you go directly to what comes after. And that's the answer to your question, is it depends on what you have after. Does that help you? Good, good. Good.
I have a question.
Hi, yes.
Yes. Could we put all the definitions at the top, like put word 1 equals input, enter a word, in word 2 equals input, enter a word? Because
Yes.
word 1 and word 2 are both, with the 1 equal sign, are both definitions.
Yeah, yes, you could, but it does depend. It depends.
Right.
There are cases where you certainly could do that, reorder these statements and have the same output, but in some cases you can't.
Okay. All right.
All right, so tell you what, I'm going to eliminate the stuff having to do with word 2. And let's explore what we've looked at so far in the picture. So that would be just if something, then do. Now that's not syntax. So we know how to count letters. So how about this? If the length of word 1 is greater than 5, colon. Now notice where my cursor is blinking. It's indented. Indentation in Python is absolutely critical. It's a major part of the programming language. The indentation means that the lines that are indented immediately below the if statement are part of the do this, right? That could be more than one line. So there could be a line here, print, print, and then I'm not indenting anymore. Okay, now let me explain that in different ways. So I'm going to put in just the one line. It's indented and print. That's a lot of letters. And I'll just go here after the if statement. Okay. Now I have committed an error here. Can anybody see the error?
You
Yeah.
already have a single quotation in that, so you need the double quotes.
Perfect, perfect. So the answer is I'm using a single quote as part of these words that I want to print, but I've also started the whole string with a single quote. So I'll instead replace it with balanced double quotes, and all is well. Okay, so enter a word, the. What's missing?
It didn't print. That's a lot of letters because it only has 3 letters and that's not greater than 5.
Exactly, perfect answer. So if you were to put, whoops, make that part of your picture here, like the input, the print, et cetera, and then there was a decision. And the decision is length of word 1 greater than 5. And if true, print that's a lot. And continue on. And in fact, down here, it said after if. But if false, you see how we skipped it? So there's the picture form of the code that you see here. Okay. Any questions?
I have 2 questions. First of all, what's the necessity of the colon after the 5?
Okay. The necessity of the colon, and it is necessary, it's part of the definition of the language of Python. What necessitates it is how computers parse, make sense of the language in the code. So, for instance, if we were to remove the colon, how would the programmer make clear that the decision part of the if is finished and the then part begins? So that's what the colon is doing for us. It's, in general, it's used elsewhere in Python, but in general, it is used to denote the beginning of a block of indented code. Okay, your second question?
Yeah, so every indented print after that would be if the statement was true, right?
Exactly. In fact, that's what I was going to add that. I was going to add that because I talked about the indentation, but I haven't given an example of multiple statements inside of an indented block, and that was exactly your question. So is this printed also? Okay, let's try it. Or is it skipped? I don't know. Let's see. Main, Python, enter a word, the. Okay, it didn't print. Neither of those printed. Let's try. I'm not going to type the rest. Oh, look at that. Okay, so Kevin, does that answer your question?
Yeah, thank you.
Good. You're welcome. Anybody else have a question? All right. What if we wanted to do either this or that? Okay, so that's where, so if some decision, in other words, true, I'm showing the wrong screen, or false, is then, this is not proper syntax, I'm just do this, otherwise, do that. We'd have, you're arriving at your decision. You have the decision, question mark, true, false. And if it's true, do this. So this is true, and this is false. Of either executing some code or skipping it entirely. Now we have a true fork in the road. We either go one way or we go another. Now let's take a look at the the actual syntax for this. And go back here. And that would be using else, colon, and then an indentation. I keep wanting to, you know what, I'm going to show you a different way. Okay, so that's not many letters. So I did what I did before, that error that I did before, but I'm too lazy now. I really, really like the single quote. I like the single quotes better than double quotes, sue me. So I want to stick with the single quotes. So here's a way that you can, another way of getting in that, handling the case where you want to use a single quote, even if you surround the string with single quotes. Now, the letter that I put in is the one above just above your enter or return key. It is the backwards facing slash, which computer people will call bash because bash. Okay, so there are certain letters that you can escape in this way. So this backslash says, don't treat the single quote like you otherwise would. All right, so let's try this now. Enter a word, joy. That's not many letters. So the decision, there's just the one decision. The length of the word is 3, and 3 is not greater than 5. So that's false. So because it's false and there's an else, it performed the sequence of instructions that are nested underneath the else.
I have a quick question.
I would love to hear it.
So, because I know indentation is important, does the word else have to always be lined up with the word if?
Yes,
Okay.
yes, because indentation is critical. So indentation looks like it's just making the code pretty, but it's actually part of the definition of the language. So where and how much, where the code is and how much it's indented is actually contributing to the meaning of your code. In fact, I would like to demonstrate an error. Now, what do you think is going to happen there? Well, I already said it was an error, right? Now, that's going to be an error. Notice that what immediately precedes the indented line is not a colon. So it's not like an if, it's not an else. There's some other words as well. Let's try that. Boom. Okay, so it says on line 10, so Python errors do try to tell you where the error took place. So on line 10, there was an unexpected indent. And there it is. Let me take a moment to somewhat slightly digress. When I'm indenting right now, I'm hitting the tab key. Now, that's okay, but another way of indenting is multiple spaces, yes? So let's see what happens. 1, 2, 3, 4. Is this okay? It lines up, it's got the same indenting. What could go wrong? Aha. Well, let me get rid of this one too, but that had nothing to do with the error. Let's try that. Okay, so because indentation is so critical to conveying your intent to the Python language, once you start indenting with tabs, all of your indents have to be tabs. If you started, on the other hand, with multiple spaces, then all of your indents have to be multiple spaces.
Does it have to be uniform for all of your code, or is it just like that chunk of code?
You have to be uniform in the entire file. Which, by the way, notice that I didn't actually answer the question you asked. You said all of your code, and I answered in the entire file, which kind of suggests that it's possible to have your code split into multiple files. Part of your program in one file and part of your program in another file. But we won't look at that until much later in the semester. Okay. Does anybody have any questions? This is one more form of statement in the if family, and that would be the Elif. Okay, so I'm going to come back to my whiteboard. So how about if decision do this, instead of writing the do this, otherwise, if another do this.
You just cut out. I couldn't hear you. You started cutting out.
Okay, yeah, for some reason, keep saying my internet is unstable. And which is weird, like because I'm on a hardwired connection. And I pay a lot of money for my hardwired connection. So I apologize. Okay, so what the heck? Otherwise, we can keep right on going. If decision 3, do this. And what the heck? Otherwise, if it's none of those, do this. So for example, if they have chocolate, get a sundae. Otherwise, if they have strawberry, get a cone. Otherwise, scream at the people who are working behind the counter, knowing for sure that there's somebody else filming you, and you'll be a sensation on the internet. Okay? So let's take a look at a picture. So here's your code, the code that has been executing before, that you wrote before. And here's decision 1. And if true, do this. That's true, and that's false. Then only if it's decision 1 is false, do you consider decision 2. And if that's true, do that. And only if decision 2 is also false, you get to decision 3, which I think I did 3 decisions. Yes, I did. Only if that's true, go to, how did I do that? I did it in sideways, slanty lines, okay? And then otherwise, if that's false, whoops. Otherwise, do the squigglies. Okay, so look at this picture. And remember that if this is true, if decision 1 is true, then you're done. You do what's in the middle, and you're done. You don't get to decision 2 if decision 1 is true. So only if decision 1 is false do you get to evaluate decision 2. And if decision 2 is true, say that 12 times fast, do you do this body of code and then come to the bottom? But if that is also false, then you get to try decision 3, and only if that is true, you do this body of code, and then you're done. And finally, the way I've written this, if none of these are true, you do this body of code, and you're done. But notice, above all, that only one path through the code happens. You can't do decision 1 and decision 3, body of codes. You can't do that. You can't do this and this. Can't happen. Only one. All right, so let's take a look at our code here. And permit me, please, to tighten this up a little bit. Okay, so let's take a look. If the length of word 1 is greater than 5, I'll do that. Elif, whoops, Elif, the length of word 1 is equal to 2, Double equal sign, folks. Okay. And I wanted to do one more choice.
So for the first Elif, you put like the word 1 is equal to 2, all in the same parenthesis, but above you did like different. Is that
You
supposed to be
caught-
that way?
Thank you. You caught a mistake on my end. Thank you. There, I made a boo-boo. Thank you, Catherine.
Yeah.
We all make boo-boos, even people who have been doing this for 50 years. Okay. Okay. All right. What do you think of this code? Let's try it. Maybe you'll see what I'm after if we try the code. So here is 1, 2, 3, 4, 5, 6. What do you think is going to get printed? Try to think. All right, so that's a lot of letters. All right, let's try it again. I'm going to print, I'm entering just 2. Now look, we've got code in there to handle the case of just 2. What do you think is going to print it? Going to be printed?
How cute with the exclamation mark.
Okay, good. And how about this one? What do you think is going to be printed? I've got on line 8, I've got a code in there to handle really long words. What do you think?
I think it'll print, that's a lot of letters.
Exactly. Remember, you only get one path through the code through the if combinations, and they operate in sequence. So a huge word, in this case, 30 letters, 30 is greater than 5. So it's going to do line 5, not line 9. Oh, 44 letters. Okay, now what should I enter so that line 11 executes? Can you tell me?
Can you do 3 letters?
Excellent idea. How about 1, 2, 3? None of the above. Very, very cool. You have learned a great deal. So now I would like to do an exercise. So if you could, in your browser, keep this window open. In your browser, also, let's go back to this GitHub link. Here is the class webpage. And there is a link here, a folder that says in class. And there's a folder that says ages. And here is whoops, then you have to click on the word ages, ages.md. Finally, we're here. There's something I haven't, that you need to be part of this, and I haven't shown it to you yet. I now realize I'm looking at the clock and it's 11:07. And very, very quickly, I'll take 3 minutes to talk about what else you need to do this. And I'm talking about the logical operators such as and or. Okay, so that would be here. So how about, well, actually, I do want to go here. So we have logical operators. Now, the word operator we've heard before. We have plus and minus. Those are mathematical operators. There are logical operators which produce trues and falses. So something like a lavender blob. Okay, so A and B. So Python will try to interpret this part and see if it's true or false. And then if it's true, it'll try to interpret this part and see if it's true or false. And if both A and B are evaluated as true, then the entire thing is true. Also, there's OR. Let's take a look at something called a truth table. So here's A, here's B, and here's A, and here's B. Here's truth table, which I totally screwed this up. I'm going to erase the whole damn thing. All right. So let's take, we're just looking at a truth table. So here's true and false, and true and false. This by hundreds of years ago. So we're looking at and. So if you said something that's true and something else that's true, what's the value of the whole expression? It would be
True.
true. Good. But for the rest of the cases, the whole expression. So the only time that an and operator delivers a true result is if both of its operators. So for instance, is 5 greater than 2? And 0 equals 0. So all of this would be evaluated as true. Let's take a look at OR, and there's a very nice symmetry. So here's OR, true, false. So if something is true or something else is true, what do you think the whole thing is going to be?
True.
True.
True, yeah. So what if something was false or the other thing was false? What would the whole thing be?
True, because you get an option.
But if both options are false,
Then it's false.
the whole thing, false. But if either part is true, because you get the option, as Milo said, true is on either side. The answer is true for an OR. Okay. So oftentimes you might surround the clauses, the separate clauses with parentheses just to make things clear. Let me rewrite this. you would say 5 greater than 2 and 0 equals 0. Okay, now I'm betting you have questions, but at this point, let's take a look at this, and you'll see why we needed to learn and or. So the idea of this program is write the code to ask for 2 ages, age 1 and age 2. And those are integers. So you remember you have to take the results of input and convert it to an integer. Input returns a string. You have to convert that to an integer. So based upon both ages, print one or more of the following. So if both ages are 16 or more, print both can drive. That sounds like an and. If age 1 is greater than or equal to 16 and age 2 is greater than or equal to 16, both can drive. Okay. So what do you think the second one is? If either ages are 25 or more, print at least one can rent a car. What does that sound like?
Sounds like an or.
Exactly, if that's an or. What about the next one? If both, well, right away, there's the giveaway, that's an and. But this last one is complicated.
That is a, if you have and, but, and or, this is if one age is 25 or greater, but the other one is less than, only one can be a senator.
Right, that you're on the right track. And it is 11:15. We don't have enough time to solve this today, so you're just gonna have to wait till next week. Or you can try it on your own. There's an idea. Now, I'll have you know that the after doing this exercise, you know everything you need to know in order to do project 1. So on, let's take a look at project 1. Projects. Project 1 is rock, paper, and scissors. And this entire program can be done with the material that I presented to you today. Okay, so input and if statements and print statements. Okay, so consider this project assigned. It will be due not this coming Tuesday, but the Tuesday next. You're ready to do this. Okay, how we doing?
Do you mind sending the link to that page as well, please?
Oh, sure. I'm going to put it in the chat, so copy it out, okay?
Thank you.
And you're familiar, you know, the chat in Zoom, right?
Yes. Yeah.
Okay, so I will select the topmost page and go back to Zoom. What I'm doing right now, the pattern's been set by Nichelle Nichols in Star Trek, right? Because, or Leonard Nimoy. When someone's watching you on a computer, you feel compelled to announce every single thing that you do, which Sigourney Weaver made fun of in that fantastic film, Galaxy Quest. Okay, Kevin, do you have the link?
Yes, thank you.
Okay, so bookmark that, please. Okay. Any
Uh,
questions concerning today's material or anything else?
I left the thing at first too, the link, but if you lose it again, just go to the website and just go to the search bar. And I just searched in his last name, and then the class popped up, and then I starred it on my profile, so I can always go back to it if I need to.
Okay, thank you. Thank you, Lee.
As for me, I'm just super excited because we've learned just about enough to make like a choose your own adventure style.
Game.
Yeah, exactly. This guy knows what's up.
Yes. Yes, yes, you have. Speaking of that, if you know some of the very first computer games were text adventures.
Yep.
If you would, let me see if I'll show you the first one. Let's
I'm
see, go
so
back to my
glad.
browser.
I'm so glad that I don't have any more classes today. I might spend all day messing around trying to make a game.
Colossal Cave. Okay, how about Colossal Cave game? Here is one of the very first computer games ever made. Okay, so there's even maps for this. I can show you a map, but you're not supposed to see the maps. You're supposed to figure this out on your own. So let's look at the date, by the way. It was developed between 1975 and 1977. I came across this in 1978. And believe me, when something like this came out, all research in computer science came to an end for a week or two. All right, so let's see if we can find some pictures and images. Images. Oh, look, there's a map. And open link in new tab. Okay, well, there it is. That's not a very good map, is it? I'm sure there's a different link where you could see the in high resolution. That's the adventure game. This gave us certain words that survive to this day. If I ever use XYZZY, that's actually one of the secret commands in this game. The word plover is a secret command in this game. Oh, complete spoiler map. How about that one? This is the hardest part right here. This twisty, a maze where all the twisty passages look alike. And I'm giving away too many spoilers, but there's a room with a dragon. That's a lot of fun. Okay, other questions?
Yes, I have a question. Can you still find this game?
Oh, yes, of course. In fact, I'm sure you could play it in the browser. I bet you there's a web implementation.
Nice, okay.
Oh, look, there's Plover. Okay. Any questions about the material that we've done today?
Does the project have to get turned in?
Yes, the project is turned in. So when it becomes due, you will have done your work on Replit, download the file to your computer, and then submit it via Schoology.
When is the project's due date? Don't mind me asking.
It will be, let's see, so it's not due this Tuesday, but the Tuesday after. So today, I don't,
Like two
you
and a
know,
half
I was
weeks.
talking
In like
about,
a week.
Yeah.
yeah, like a week and a half. But like I was saying before, research and teaching says teachers should expose a little bit about themselves. So I'll share some more. and that my learning difference is time. I'm a computer person and I do a lot of work with real-time operations, real-time control. So I know how to process microseconds. I know how to process milliseconds, but much longer the time span than like a second is, I can't deal with it. So when you ask me, when's it due? It's like, look at the calendar. I
That's
can't
super
tell you when it's
valid.
due. Okay. Anything else from anybody? I got another question. I have one additional homework assignment for you. Everybody think of something that they like to do, that they would consider a treat for themselves, and your homework assignment is to go do it. Okay. All right, so if there's no other questions, then we can end a little early.
I can't do our homework assignment. The only thing I do is play football, and I hurt my knee, so I can't do that. So
I'm sorry, Lee. Is your knee going to get better?
eventually,
Good. You were on a team?
We were boot.
yeah, I played at Carthage.
Uh-huh. Hey, is anybody doing something that we can celebrate? Okay, you all suck.
I don't know. I don't know if it's not much, but yesterday I finally learned how to ice skate.
Wow, yeah. I, I ice skating is difficult. How many times did you fall?
Like a good 5 times.
Mhm.
But yeah, I eventually got off the wall, and I've been ice skating like twice before and not gotten off the wall because I didn't want to fall in front of other people.
Where is the local ice skating rink?
So I live in Union Grove, which is about like 30 minutes from Carthage, and
Oh.
there's a free outdoor ice rink in Waterford, which is 20 minutes from my house. So it'd probably be about like a 50-minute drive from Carthage, but it's free, and they have like skate rentals there for like specific times. I didn't see exactly, but they might have it on the village website. But
Mhm.
like if you have your own skates, it's free. And I'll try and see if I can find the link to the rentals when they have rentals.
Well, for those who are at Carthage, if we have a sufficiently cold winter, you could always go to the middle of Lake Michigan, which, by the way, I'm kidding. I would not. It's probably you'd go ice skating, sure, once. So, okay. All right. Thank everybody. Thank you all for being here, and I look forward to seeing you on Tuesday. If you have questions, drop me an email. Okay. Bye, everybody.
Bye.
Thank
See you
you.
Tuesday.
Bye.